Hello everyone. This lecture is exclusively recorded for third year BSc student of BK Birla College, Kalyan. This is mathematics class, paper 1. In this lecture, we will define the surface integral for a vector valued function, and we will also solve example based on surface integral. So our aim is to define surface integral for vector valued function and problem based on it. So let me define surface integral. For vector valued function. So let capital S be a surface in R3 parameterized by alpha from T subset of R2 to R3 let f be a function from R3 to R3 be a continuous vector valued function then surface integral is defined as is denoted by f dot ds or surface integral of f dot n cap ds, right, and defined as surface integral over s f dot ds is same as double integral over t f of alpha of x comma y dot product with dou alpha by dou x cos dou alpha by dou y dx dy. This is also called as surface integral over s f dot n cap ds. So what is n cap here? N cap is unit outward normal to surface S. In physics term, this is also called as flux. So if you want to find out the flux of any field, then basically you have to find out the surface area. Well, let us take some example to elaborate this definition, or to understand this definition, or to use this definition. We will have example based on it. Question: Find surface integral of f dot ds, where S is the surface of cylinder x square plus y square is equal to 16 in the first octet, cut by z is equal to 0 and z is equal to 5. So let me draw the surface. So I am interested only in the first octant. So basically you can see a cylinder of this side something. So this is z is equal to 5, this is z is equal to 0, and this surface we are interested, which lies in the first octant. Okay, so to parameterize this, the best way to have the solution cylindrical transformation. So let alpha from T subset of R2 to R3 be a parameterization for surface S defined by, so how we are going to define this? Alpha x comma y is equal to, so we will be using the cylindrical coordinate, so I should say L alpha. So this on the surface, on the cylinder surface, so basically this on this surface my radius is always constant, right? So and that is 4 basically, so it is 4 cos theta, 4 sin theta, and z is z, so that is cylindrical coordinate, and the parameter are here theta comma z. Right? So what is parametric domain? So t will be, so if I take projection of this, it will be the first octant, first quadrant, so my projection will be of this, it will be in this form. So disk in the first octant, first quadrant, where uh, theta will goes from 0 to pi by 2, and even you can see that your z ranges from here 0 to uh, 5, right? So t is basically it is set of all theta comma z such that theta is between 0 to pi by 2 and z is between 0 to 5. So if I solve this, then you need to find out your dou alpha by dou theta, that is 4 minus 4 sin theta, 4 cos theta, 0, dou alpha by dou z, that is 0, 0, 1, and dou alpha by dou theta cross dou alpha by dou z. This product is also called as fundamental product. So this fundamental product we can find out. So I have just calculated it, that cross product I can give you straight away. So that fundamental product is 4 cos theta four cos theta 4 sin theta, and it is 0. So that you can verify. And for going for the surface integral, so we also need to find out f of alpha theta comma z, which is f of alpha theta comma z. We have already seen. I think I have not given the function, so let me write down the function also. Yeah, in the question where f of x comma y comma z is given as z comma x comma minus 3y square z. This is what my f of x comma y comma z. So I need to find out this. So it is alpha theta comma z is 4 cos theta 4 sin theta, and z is z. Right? So this is my x, this is my y, this is my z. So it is, according to definition, f has zx, z is z, x is 4 cos theta, and minus 3y square, it is minus 3y square z, minus 3y square z, that means 4 sin theta square and z. So it is z comma 4 cos theta comma 16 3s are minus 48 minus, so cos sine square theta z. This is what my f of alpha theta z means. So let me write down our solutions in a step. So your first step should be parametrization. This is first step. Second step should be, you should find out the fundamental vector product. That is your second step, step 2. Step 3, you should find out the functional value. And the step 4, you should use the definition. So, okay, step 4 we will say find out the dot product. So let's find out the f of alpha theta comma z dot product with dou alpha by dou r cross, here it is theta now, dou alpha by dou z, and that is z comma 4 cos theta comma minus 48 sin square theta into z dot product with what is the fundamental 4 cos theta 4 sin theta 0 dot product with 4 cos theta 4 sin theta comma 0. So this dot product will be 4z cos theta plus 16 sin theta cos theta. Okay, so and now the step 5 is use definition. So surface integral s f dot ds is double integral over t f of alpha r comma theta into dou alpha by dou r cos dou alpha by, I should say here theta comma z, because these are the two parameters. Dou alpha by dou theta cos dou alpha by dou z into d theta dz. So it is theta is from 0 to pi by 2, z is from 0 to 5, it is 4z cos theta plus 8 times sine 2 theta. So because sine 2 times sine theta cos theta is sine 2 theta. So 16 can be written as 2 into 8. Okay. And here order of integration will be dz d theta. Right. So I'm not solving now this. So I hope you will complete this. And this calculation will leads to answer as 90. That you can check. We will in a class. I will definitely ask whether you get this answer or not. If you have received, then well and good. If you have not received, then we will try to find out. Then I will solve actually in a class. But now I'm keeping this as a homework, and I hope you will definitely complete this. Let me have one more question. So two more questions. So the question number second. F is given to be So f is given to be f of x comma y comma z is given to be xy I plus yz j plus xz k, and S is the surface of the solid enclosed by the paraboloid z is equal to 1 minus x square minus y square, and the plane z is equal to 0. Okay, so let's draw this paraboloid. So this is how the paraboloid z is equal to 1 minus x square minus y square. So we have to take a paraboloid which is above the z equal to 0. So this portion of paraboloid will come. So solution. So the first step is basically we have to find out a parametrization. So let alpha from T subset of R2 to R3 be a parametrization for surface S. This is surface S. So how alpha, so now I will use now here the radius is always changing. So there are two ways of solving this. I take alpha x comma y parametrization as x comma y comma z is 1 minus x square minus y square. This is one way. Or we can use the polar cylindrical transformation. So you can see that x is r cos theta, y is r sin theta, and z is equal to 1 minus r square sin square theta minus r square cos square theta. Yeah, sorry. So that will be x square plus y square will be r square. So it will be r comma theta, and it will be x is r cos theta r sin theta, and it is 1 minus r square. I will use this because what happened, uh, because even if I do this, then after when I take the projection, my projection will be a disk whose radius is 1 now, and then again r will be 0 to 1 and theta will be 0 to 2 pi. So again, instead of using polar later on, I will be using this, right? Then second step is you need to find out dou alpha by dou r cross dou alpha by dou theta. This is what second step. So I'm not writing now. I hope you will do this. Then third step, you need to find out f of alpha r comma theta. Now here it is f of it is r cos theta, r sin theta, and 1 minus r square, and then apply the definition. So this is x, this is y, this is z, and what the definition says, it is where it is, yeah, xy, yz, and zx. Yeah, so it is xy means r square cos theta sin theta, then yz, that will be r sin theta minus r cube sin theta, r cube sin theta. Let me write down in a separate space. It is r square sin theta cos theta, comma r sin theta minus r cube sin theta, comma r cos theta minus r cube cos theta. This is how the f will be. Step 4, you find out the f of alpha r comma theta dot product with dou alpha by dou r cos dou alpha by dou theta. So this you need to find out. So I just want to tell you one more thing here. What will be the t? My t is, so here you can see that t basically projection is a circle x square, disk x square plus y square less than equal to 1, and if it is this, then your r range is very clear. R will be 0. So how will I define t? So t is basically set of all r comma theta such that r between 0 to 1 and theta between 0 to 2 pi. So this you can do. And the step 5 is basically use surface integral definition. SID means surface integral definition. So it is surface integral f dot ds is equal to double integral over t f of alpha of r comma theta dot product with dou alpha by dou r cross dou alpha by dou theta dr d theta. And this you can calculate. I'm not solving here. Somewhere I have the answer which you can do it later. Means I am not giving a direct solution to this. So answer to this is pi by 3. So definitely in a lecture we will discuss whether you really got pi by 3 or not. Right. There is a question number 3. So f of x, y, z is given as 2xy, comma 2yz, comma 2xz upward across the portion of the plane that is tetrahedron x plus y plus z is equal to 6 that lies above the square, x is between 0 to 3 and y is between 0 to 3 in the xy plane. So this means that when you say x is 0 to 3y, so this projection t is already given. That is what it says. And alpha will be, this can be, this, it should parameterize my tetrahedron. So alpha x comma y is x comma y comma 6 minus x minus y. This is what alpha step 1. Step 2, I'm not writing, that you can easily find out. Step 3 is basically you need to find out what is step 3. I have written f, that also you can find out. Step 4, you need to find out f of alpha x comma y dot product with dou alpha by dou x cos dou alpha by dou y. So here I just let me write down what is t. So t will be basically set of all x y such that x between 0 to 3, x comma y between 0 to 3, right? So for the fifth step, when you will find out the surface integral f dot n cap ds, I should, anyway, that doesn't matter. This is same as, so t is 0 to 3, 0 to 3, and f of alpha of x comma y dot product with dou alpha by dou x cos dou alpha by dou y. This you need to find out, dx dy, and this integration will be, if you solve, this integration will be something minus 297 upon 2. So I suggest that you please cross check whether these answers are correct or not. It may happen that there might be a corrections in a calculation. So, or maybe if you find any corrections in a calculation, do let me know. We will definitely discuss them in lecture. Thank you so much.